Myself Archana Hatkar. I will be taking your BXC, that is Basic Electronics Engineering, the first unit, Evolution of Electronics. Vacuum tubes. In 1904, the simplest vacuum tube, the diode, was invented by John Fleming. In 1907, T. Forrest invented the triode. Diode is having, since the name diode, it consists of two electrodes, that is anode and cathode. This is the construction of vacuum tube. Here you are having the cathode, anode, control grid and glass tube. Here the vacuum tubes are made up of glass where the air was evacuated. ENIC computer, University of Pennsylvania in 1946. This was the computer which was first invented. ENIAC computer, headed as giant brain by the press, 1,000 times faster than the electromechanical computers. Here the 17,468 vacuum tubes were created, which consumed 150 kilowatts. Input was possible from IBM card reader and the frequency was 100 kilohertz. The first transistor, this is the picture of first transistor. The vacuum tube was very bulky, fragile device which consumed a significant power. In 1947, Shockley Bradley at Bell Labs invented the first transistor. The first transistor was a point contact transistor. Next, the semiconductor technology grows. Here the bipolar transistor continues to be an important device, both as a discrete device as well as the IC. However, in digital circuits, MOS, that is metal oxide semiconductor field effect transistor, has surpassed the bipolar transistor. In 1930, patent filed by Littlefield for FET. In 1958, Jackie Kilby, Texas Instruments, demonstrated the first IC, that is bipolar junction transistor, and resistor and capacitor. This is the semiconductor technology. Here you are having the package, chip is there. This is modern semiconductor technology, consists of silicon wafer. The picture is like this. Then here you are the diffusion permanence, modern semiconductor technology. This picture shows you the semiconductor technology. Now there are certain components which are used in our day-to-day life. Some components are called as active components, some are passive components. Now the passive components are resistor, LDR, thermistor, capacitor, inductor, switch, variable resistor and the transformer, and the active components are transistor, BJT, JFET, MOSFET. Also the active components consist of the operational amplifier. These active components you require the power supply. What is the difference between the active and passive components? Active devices inject power to the circuit, whereas the passive devices are incapable of supplying energy. Active devices are capable of providing power gain, and the passive devices are incapable of providing power gain. Active devices can control the energy flow within the circuit, whereas passive device cannot control it. And external power is required to start basic operation of the active device. There no extra power is used for the passive device. Now there are certain parameters for the conductor, semiconductor and the insulator. Number of valence electrons in the case of semiconductor is 3 or less, conductor is 3 or less, semiconductor 4 and insulator 5. Parameter is conductivity, high, medium and negligible. Semiconductor types, there are different types of semiconductors. First is called as the intrinsic semiconductor, second is called as extrinsic semiconductor. Extrinsic semiconductor is again classified into p-type semiconductor and the n-type semiconductor. Here the intrinsic semiconductor, when it is doped with certain impurities, those are called as the extrinsic semiconductors. The doping may be the trivalent impurity or it may be the pentavalent impurity. Now when you talk about the n-type semiconductor, pentavalent donor impurities are there. Arsenic, phosphorus, antimony and bismuth are used. Here the free conduction electron from the Sp atom is created. When you talk about the p-type semiconductor, this is the trivalent acceptor impurity where hole from boron atom is free. That is boron, indium and gallium are the examples of the semiconductor. When you talk about the p-n junction diode, which consists of one p-type and n-type region is formed together and the p-n junction is created. At the instant of junction formation, free electrons in the n region near the p-n junction begin to diffuse across the junction and fall into holes near the junction in the p region. Then the depletion region is created. This is also called as the barrier potential. For every electron that diffuses across the junction and combined with the hole, a positive charge is left in the n region and a negative charge is created in the p region. forming a barrier potential. This action continues until the voltage of barrier repels further diffusion. Now diode